Breaking down acrylamide formation. In order to understand how the Maillard reaction occurs between glucose and asparagine in the presence of glutathione, it is necessary to use reagents. These reagents will help calibrate the system of the liquid chromatography to help create a calibration curve. In this way, we will be able to quantify those reagents in the sample. It is expected that many of the reagents that are intermediates or end products formed between glucose and asparagine during the formation of acrylamide. To achieve this purpose, we created a stock solution of every reagent, and all of them will be dissolved in DI water to a concentration of 5 milligram per milliliter, except for the oxidized glutathione, which will be dissolved in hydrochloric acid. All the stock solution will be kept at -20°C until they are used. In this experiment, the Maillard reaction was studied using glucose-asparagine model system, from which we can expect the formation of specific intermediates and final products. Based on this model, the author evaluated the effect of glutathione in the formation of acrylamide. The reaction was carried out using high temperature, 180°C, and 10 vials of both model solution was used. These models were prepared using creating a solution of 100 millimoles of glucose mixed with 100 millimoles of asparagine. And to prepare the glutathione model, the same proportion of glucose and asparagine were utilized, but 12.5 millimoles per liter of glutathione was added. They were then immersed in a silicone oil bath because no liquid water can sustain that high temperature at 180°C. Samples were taken every 6 minutes for 60 minutes. They were diluted with DI water and filtered through 0.22 micrometer polyether sulfone filters to monitor the progress of the reaction using a liquid chromatography and mass detector. The compounds that form at these high temperature were separated using a chromatographic column at 40°C. Samples were eluted using a combination of acetonitrile and formic acid. Acetonitrile is solvent A and nonpolar, and formic acid is solvent B polar. The polarity of the mobile phase is decreased progressively by adding proportions of acetonitrile. In other words, the more polar compounds will come out first, the less polar compound come out later. After the compounds were separated in the column, the compounds are ionized, and the mass of the ionized fragments are detected, allowing the identification of the intermediate and final products of the reaction. Thank you for listening to my presentation.